Hey guys, Mr. Simonini here. This video is about solving in factored form, which is what you're going to be doing on homework A for our last topic in quadratics. It's crazy that we're almost done with it. Anyways, just a reminder, this is, again, this first example right here, I already have it done for you. I just want to just remind you, hey, we did vertex form already. This is what we did in vertex form when we had to solve. So don't forget that, add 10, all that stuff. We actually did that first semester. And again, if you're a person that likes the arrows, that's hopefully a reminder of how to do that. Standard form is what we just did. It was the beginning of the e-learning. With standard form, how you solve, just a reminder is there was a really, really important formula out there that you just basically follow. You find A, B, and C. You had to make sure A, B, and C was on the same side. You plug it into the formula, plug it in your calculator, and then you got your answers. Don't forget our answers are x-intercepts. So again, those are just reviews. It's not what we're going to be doing on the homework today. What you're going to be doing now is you're going to be solving something that's in factored form. But remember what factored form is? Factored form is whenever you have a binomial times a binomial. So for example, and again, it could also be a monomial times a binomial at times, but mostly is usually binomial times a binomial, or you can have this going on, just to be clear, a monomial or a constant. It can be out there too at times, but something like that can happen as well. So again, this one is in factored form. Now, just to be clear, do not make this more complicated than what it is. This is actually really easy to solve. That's one of the advantages of factor form for quadratics. Remember, whenever we solve this, what we're doing, we're finding x-intercepts as a reminder. Remember, x-intercept, that must mean y is 0. So when you're solving, if you see y in it and you're solving it, you can assume y to be 0. So again, I'm just going to actually erase this y here and just put 0 there instead. Now, to give you the reason why this works, I'm going to show you a shortcut soon, but there's a property out there called the zero product property. So I'm just going to talk about it real fast and just do this problem, and then I'm going to show you a shortcut of a shortcut way of doing the problem. Anyways, zero product property, again, what it is, it helps us solve in factored form. Now, what it is whenever you have two numbers being multiplied, again, we don't know the numbers, let's just call A and B. And we know if we multiply them, it equals 0. So this must be true. Okay, we're assuming this to be true. It must mean that A is 0 or B is 0, and that's huge. So for example, let's just say I have 5B equals 0. Well, I already know that 5 isn't 0, so that must mean that B must be 0. Okay, that's kind of the idea. Or, let's say you have, A times 12 equals 0. Well, that must mean A is 0. So again, it's just saying whenever you multiply two numbers, the product of two numbers, and it equals 0, that must mean one of them is equal to 0. Now, what you're going to see is we're going to be dealing with binomials. So if I put this in parentheses, maybe this makes, it's going to make sense later. If you have something in parentheses times something in parentheses and it equals 0, then one of them must be 0. Wait, what do I mean? Well, let's look up here. You have x plus 5. Consider like this is your A, and then you have x minus 4. This is like your B. And you're multiplying together because remember, when parentheses touch, that's multiplication. It equals 0. So with saying this, this must be true. X plus 5 must equal 0, or x minus 4 must equal 0. And that is true. So what you do is you just solve both of these equations. You get x equals negative 5, or you get x to be 4. And that's all you have to do. This is the answer when you solve it. These are my x-intercepts. Now, something that you might have noticed, wait, the shortcut, I think I get the shortcut. It says opposites. And yes, you are correct actually, but just be a little careful. If I throw a number in front of x here, that changes it. Understand there was a 1 here. What you always want to do is kind of opposite of sliding and dividing when we factored. But if you slide that there, and you slide that 1 there, and then you take the opposite of that number, that will work. I'm going to show you what I mean in further examples. But anyways, if you just want to go ahead and do opposites, that is a shortcut way of solving this problem. Again, that's what's a really good advantage of factor form is that you can figure out the solutions really, really quickly. All right, so let's go ahead and go on to the next one. So what I mean is, okay, so like if you look at my second example, it got y equals 3x minus 4 plus 8. Remember, y is 0, so you can always think y is 0 there. This is a longer way of doing the problem. You can set both parentheses equal to 0 and then solve both of them. You get 4 over 3 or x equals negative 8. That is the longer way of doing the problem. Or you can do it this way. And this is really, I like doing it this way because it goes a lot faster. Whenever you have a number in front, what you do is you put the number underneath the constant. You can kind of X it out, and then you just think opposite. What's the opposite of negative 4 over 3? Well, that's just 4 over 3. And then what is the opposite of 8? Well, that would be just negative 8. So this is, I would say, is the shortcut way of doing it. So I really suggest doing it that way because you can do it really fast. Or you can do it the longer way, which is the more, you can set one parenthesis to equal 0, set the other parenthesis to equal 0, and then you get your two answers. I'm going to go over a situation that occurs sometimes. Whenever you have an x on the outside, so this is a really important rule, x is outside of a parenthesis, then x equals 0 is one of your answers. So if you look here, this is a good example where this is happening. Since x is outside of your parenthesis, x equals 0 is one of your answers. Or, again, you just do the opposite there. It would be just x equals negative 7. So, again, you just do opposites and just remember if x is on the outside, x equals 0 is one of your answers. So another example is right here. Even though there's a 7 in front, it's just 7x. So if you think about it, 7x equals 0. Or x minus 3 equals 0. So again, you can do it that way if you really want to, but just know this rule. If x is on the outside, x is 0 or x is 3. Again, if you really want to do it the long way of doing it is you get 7x equals 0 or x minus 3 equals 0. So when you divide by 7, you get x equals 0 or x equals 3 here. So again, it doesn't matter which way you do it. But I really suggest doing it the shortcut way. One last problem. So just to be clear here, there is no x with the 8. So what you do is, since there's no x with the 8 in this problem, let me zoom in here. Since there is no x with the 8, you can just ignore the 8 for this. So if you look here, all you need to do is just focus on swinging that 7 underneath, swinging that 10 underneath, and then doing opposites. Okay, so again, now you just do opposites. Okay, again, you ignore that 8 because there's no x with it. Okay, so my answer is going to be x equals 1 over 7 or x equals, sorry, that was a 10 here, x equals negative 19 over 10. Okay, and that's all you need to do. So again, whenever there's a number in front of x, you want to swing it underneath what comes after it, and then just do opposites. That's kind of the quicker way of doing it, these problems. Now again, if you like doing it this way, because this way makes more sense to you, then that's fine. Your homework today, make sure you look at it, make sure you look at the answer key, make sure you're doing the problems right, and then please let me know if you have any questions. Thanks.